There, that's it. This is a wormhole. There's no need to spit like that. Rom, suppose you want to get from here to here, but it's too far. Yeah. A wormhole warps space, so you can cut the distance through another change. 17 seconds. 17 fucking seconds out of a 3-hour movie. This is all an explanation of the wormhole principle. There is, in fact, nothing else there. What kind of popular science is it? Now listen to a normal explanation. Wormholes are things that can take us anywhere in the universe in seconds. Yes, it's a miracle. It is necessary to tell about it from the first grade in general. They just showed off. Like everything is clear. That's the truth. Really, after this analogy, you don't have any questions at all about how exactly space is curved, and not two-dimensional, but are three-dimensional one. How to pierce it, how to sew the resulting holes can fail itself. Or is it necessary to create artificially of some size? Won't the curvature of the space inside kill us? If there is a risk of getting lost or lost, and the further it goes, the more and more questions there are. But no, we just pierce the space and let's go. Because of this, by the way, there are a lot of misconceptions that there are portal singularities inside, parallel worlds to the past, to dinosaurs, connection with other dimensions. There is a lot of fantasy, but not all of this has been proven even in theory. In this issue, we will thoroughly understand what is true and what is not. We will discuss whether a wormhole can lead to another universe, how to make a time machine out of a wormhole, and what does black and white holes have to do with it. Why do we need an additional 6 dimensions, and what are our chances of discovering a ready-made burrow or even becoming one ourselves? Let's go. But before you dive into wormholes, you need to prepare. Well, because imagine, you emerge from it, and there is not a quiet and peaceful space, but a galactic battle, starship shootouts, aliens, hyperblasters. Here's how to be prepared for this. No courses will be able to cope here. We need something more serious. For example, Space Action Star Conflict is a multiplayer game about a corporation's war for dominance in the galaxy. In it, you control a spaceship, which you upgrade yourself at the base and capture territories in the next world, fight with aliens or troops of empires. You can join corporations with friends and other players, or as a pirate alone hunts for resources in the open world mode. The game is constantly updated, new ships, locations, weapons appear. And personally, for example, I particularly like gravitational lenses, singularity generators and wormhole projectors. Well, that's exactly what we're talking about today. In general, the arsenal is huge, suitable for any mission from reconnaissance and attack to siege and support of the Union. Follow the link in the description. There you can not only download Star Conflict for free, but also pick up valuable bonuses. As soon as wormholes become a daily reality and we have to save or capture the galaxy, you will already know what to do. Have successful missions and easy victories in battles with other players. So now we're ready for anything. And to begin with, let's quickly run through the history. Who exactly invented this black and why? 1915th year. Einstein completes the general theory of relativity, which describes gravity as the curvature of spacetime by mass or energy. It looks something like this, but for simplicity we will use a two-dimensional analogy. Although it is not so accurate, it is much clearer. 1916th year. Carl Schwarzschild discovers that Einstein's equations can describe such a deep dip in spacetime that an event horizon appears around at a boundary with monstrous gravity through which nothing can escape, not even light. Now we call these black holes. Everything that crosses the event horizon is unable to return back and inevitably falls on a singularity, a place with infinite curvature, the space of time. In the same 1916th year, Ludovic Flamm develops the idea of a Schwarzschild. If there are black holes in which objects end their life path, then if we consider spacetime boundless, without any edges, there must be white holes in which objects begin their existence. They look similar. They have both a singularity and a horizon. Only here, on the contrary, nothing can get inside the white hole, everything just flies out of it. In general, this is some kind of anti-vacuum cleaner, the complete opposite of a black hole. The only thing is that if later it became clear that black holes can exist in reality, well, for example, this is, of course, the stage of evolution of stars, then everything is much more complicated with white ones. We have not seen processes in the universe that could lead to the emergence of such an extravagant object. They are not even on the AliExpress. So white holes are only a dry theory so far. Well, at the beginning of the 20th century, in general, all of the above was just calculations on a piece of paper. So we'll see. From this moment, the most interesting begins. It turns out that the boundless universe requires that objects from a white hole have the opportunity to get into a black hole in two different ways. I depict such an attachment diagram. It is quite difficult to explain why this should be the case. Here it is necessary to use the coordinates of the Russian Sakarish, but they are so difficult to understand. I've suffered so much in general that I don't want you to suffer too. So let's just accept that there should be two paths. And the most interesting thing is that one of them passes through our universe, and the other through some other. Yes, seriously, the existence of white holes presupposes the existence of another universe. It is connected to ours through an isthmus like this. This is the wormhole. These are also called the Einstein-Rosen Bridge. On the plane of the mouth of the wormhole is a circle, and in three-dimensional space it will be a three-dimensional step. By the way, in fairness, explain it in Interstellar. And it may seem cool. Let's pack our bags, travel to other worlds. But here our old friend is waiting for us to break off. The fact is that, like the border, now such a wormhole is impassable. All because the Einstein-Rosen Bridge is not a static object. He appears very quickly and disappears very quickly. And even when the isthmus appears, we don't have enough time to skip it. But it's better to look at the dynamics yourself and it will become clear that there is no way at all, just without options. First, there are two white holes in two universes, nothing can get into them by definition. And at this stage, the passage is closed. Over time, their singularities converge, unite, annihilate and disappear. All the bridge appears in, it would seem, ran. It is still open, but the horizons of events here are not going anywhere and do not allow them to cross. Yes, after some time they merge and disappear, but in their place, event horizons of black holes instantly appear, which form a kind of trap. Once under them, you will not be able to climb out the wrong way, not back. Instead, you will inevitably fall on the singularity of one of the two black holes that form after some time in different universes. The only option to go through such a wormhole is to move faster than light, catch up and cross the fleeing horizon. But we are all made up of brodyons of particles slower than light, so, alas, this will not work. And the brain of the Rosen bracket is not passable for us. Well, that's fine, and actually, I didn't really want to. Especially since this is another world. This is not the parallel behind the multi-world interpretation of quantum mechanics, where there is your double with a different fate. That's another story altogether, although there is something else interesting here. Once under the event horizon of a black hole, while you are still flying to the singularity, you can see light from another universe that crossed another horizon and was also trapped with you. The opportunity is simply unique, because no one from our universe will be able to see this even in a photo. So if you accidentally got into such a batch, do not waste time, stare around and enjoy the spectacle. But back to the story. Because of its impassability, the Einstein-Rosen Bridge was not particularly interesting to scientists, even taking into account the fact that there may not be two universes, but an infinite number. And even when it turned out that 2 points of the same universe can connect in this way, and not different ones, the main thing is that it should be curved properly. Such an Einstein equation is also allowed. However, everything changed in the 1980s thanks to this and this person. Carl Sagan, who signed the science fiction novel Contact about communication with extraterrestrial civilizations, turned to Kip Thorne for help. He needed to come up with the most scientifically sound way to travel in space and faster than light. Yes, this is the same Kip Thorne, the author of the idea of the film Interstellar. Nobel Prize for the discovery of gravitational waves in the year 2017. He was interested in wormholes before it was mainstream. Well, in fact, he created it. Actually, yes. In general, Thorne found such solutions to the equation of general relativity that create a passable wormhole, depicted in exactly the same way as the Einstein-Rosen Bridge. But in fact, there are important differences. First, the traversable wormhole has nothing to do with black-white holes. Secondly, there are no event horizons in such a wormhole, so it is passable in both directions. Third, there are no singularities inside it, no monstrous tidal forces that will tear you to pieces. Fourth, it exists and does not collapse for quite a long time in order to have time to fly it. There are other features, but this is the main one. The main thing is that passable wormholes can be. The theory, however, does not describe how they appear, from what, for how long, but at least does not prohibit their existence. The only thing is that unlike black holes, wormholes are much more complex objects. Therefore, it is considered that they are not formed by themselves, they can only be created by art. Yes, it may require a lot of energy, maybe some incredible technologies of the future. But there seem to be no fundamental difficulties. Except for one thing, see that the traversable wormhole does not form the same way as the Einstein-Rosen Bridge in its narrowest place, the presence of so-called exotic matter is necessary. This is not a bounty or passion fruit. Its singularity is that it has a negative energy density. Well, if you simplify the negative mass, do not confuse it with antimatter, there is the opposite, only an electric charge. And exotic matter has anti-gravity properties that work on repulsion and do not allow the wormhole to shrink and collapse. Oh, well, everything is clear, we have arrived. In short, dry the oars. No passable wormholes for you. This does not happen in nature. It would seem that in fact we know where exotic matter meets. For example, vacuum fluctuations near the event horizon of black holes, due to which Hawking radiation arises, are also exotic. There is no experimental confirmation here, but the theory is quite convincing. So, yes, the state of matter is rare, unusual, but not impossible. The problem here is that it has been studied very poorly, and so far we do not know whether it is possible to create a sufficient amount of exotic matter inside a wormhole. Well, let's assume that it is possible, since the theory does not forbid. So let's figure out how to create such a wormhole. To begin with, let's understand how to bend the space of the universe so that two distant points turn out to be rows. Well, in fact, it may not be necessary to do anything, because it is already distorted by massive bodies or any other energy. However, somehow changing the curvature in this way will be quite difficult. Therefore, we can only hope for a natural curvature and look for the bends we need. But perhaps when the quantum theory of gravity is created, we will find an easy way to bend space, well, just like bending out of paper. Something else is more important. Unlike all known natural phenomena, the existence of passable wormholes requires not 3 dimensions, but more. It is necessary that our 3-dimensional universe be embedded in a hyperspace of a larger dimension, as a 2-dimensional sheet of paper is embedded in 3-dimensional space and curved in it. Moreover, not one, but as many as 6 additional changes are required. Alas, we do not know whether they exist or not. And it's very difficult to check it, staying within only 3 dimensions. But no one forbids us to assume something. Then we can hope that 2 distant points, between which billions of light years in hyperspace, will be at arm's length. And just imagine, you stretch out your hand. Oh, I'm sorry, you stretch out your hand, and there are distant galaxies, the stars are just awesome. They just look. Hyperspace is like a window, we can't. There are no other dimensions available to us except the 3 in which we are trapped. That's why we need a wormhole. We need a tunnel consisting of these 3 dimensions. But what is even more interesting, perhaps the opposite is true. Our space is straight and flat, just like the endless step. But hyperspace has a constant negative curvature. This is called the anti-de-Sider space. In it, the farther away, the distance between objects is getting smaller, smaller and smaller. And wormhole creation is getting easier and easier. Look, let's say there is 1 billion kilometers between 2 points of our space. If we step back from them by a centimeter into hyperspace, then the distance between the new points will already be 1,000,000 kilometers, and after another centimeter, thousands of kilometers, and after another centimeter, 1 kilometer. And so on, thanks to the curvature of hyperspace. The further we penetrate into it, the shorter the distance in any direction becomes. Of course, we haven't been there, we don't know for sure, but it may well be. And just imagine, a wormhole in such hyperspace will have a length of 5 centimeters. Plus 5 centimeters is nothing, and a meter 10 centimeters is generally a walking route. It turns out, it remains only to build the mole Naru itself. And there are even several ways to do this. The first is quantum. At the microscopic level, space is filled with quantum fluctuations. Vacuum, that is, seethes with all kinds of fields, electromagnetic, electronic, gluon, and so on. If there are gravitational quantum fluctuations, then surely there are also small wormholes that can be captured, stretched for human scales. And that's it, you can travel. The second method is quantum classical. You need to bend the space, push it in one place, pierce it in the opposite and sew it together. In addition to the difficulties with the curvature, another one arises here. At the puncture site there is a boundary where space-time ends abruptly. This is a singularity. It is governed by the laws of quantum gravity, which, alas, we do not yet know. And the third method is classical, just the same, unlike the previous two, does not require quantum gravity. It has been proved that with the help of a series of smooth deformations and twists of spacetime, it is possible to obtain a wormhole and avoid the appearance of a singularity. But it's just like kneading dough or making a dog out of a sausage ball. However, to do this, you still need to curtail time so that something moves from the future to the past. And this, I'm sorry, actually, we already need a time machine, which, of course, we don't have. We have not yet learned how to bend such a highly changeable world. If none of the methods work, then you can rely on the primary wormholes, which may have arisen at the time of the Big Bang. But here nothing depends on us at all. And since I said about the time machine, then yes, it can be created from a ready-made wormhole. To do this, it is necessary to move one mouth relative to the other. According to the theory of relativity, the faster an object moves, the slower its time flows. Accordingly, time will slow down at one mouth, and at the other it will flow the same way. And if you go through the wormhole you will find yourself in the past. Well, look for yourself, a man comes out of a wormhole when it's 05 minutes on the clock. Where did it come from? And he came from the future, from another mouth of time in slow motion. He also entered it at 005 minutes. But it so happened that he traveled back in time from 010 to 05. Yes, it's a bit confusing, but still workers. The only thing that such a time machine can transfer is not to any past, but only in the moments after the creation of the wormhole, not before. So don't even dream about dinosaurs and killing Hitler. There is another way to make a time machine on the market. To do this, it is necessary to place one of its mouths near an object with very strong gravity. Time slows down quite a bit there, too. In general, standard relativity theory chips with time dilation are used here. It is necessary that one of the used to be in the past relative to the other. And yes, there are also temporary paradoxes. Some believe that they can be resolved, some do not. But this is a completely different story. And in fact, there are already a lot of models describing wormholes. For example, there is even an assumption that aesthetic matter is not needed, and special fields from hyperspace restrain the wormhole from collapsing. By the way, he counts them exactly. Professor. Interstellar has models describing ready-made burrows consisting of one black and one white hole. These are passable only in one direction, and if you consider that in real black holes you may not get to the singularity, but rather fly by, then it sounds quite convincing. In general, there are encouraging calculations. One thing is upsetting, this is the only thing we have. There is not the slightest hint where to look for these wormholes in the universe. What could be the reason for their occurrence? How to detect other dimensions of hyperspace? How to get exotic matter? How does gravity work at the quantum level? These are all big questions. Of course, this is not a reason to stop and you need to look for answers to them, because well, just think about what's at stake. Wormholes are, perhaps, our only chance. Travels through the universe of light. Let me remind you that galaxies, nebulae, Andromeda light flies for 2.5 million years. I'm already silent about the rest, they're up to tens of billions. If we want to explore worlds so far away, we will have to invent something new. We'll have to somehow grab the universe to overcome the light barrier. Just the same, wormholes are the most adequate candidate and you need to cling to it with all your might. But the most interesting thing is that even despite all the fantasticism of this story, we, without noticing it, are slowly moving towards the denouement. The fact is that one of the primary tasks of fundamental physics is the creation of a quantum theory of gravity. When it will appear and how much more acceleration it will need to build, we do not know, but most likely, this is exactly the missing puzzle that will give an accurate answer whether it is possible to build a wormhole or not. Well, of course, it's clear what everyone wants, but the most important thing is that this answer is received as soon as possible. That's it. Don't be afraid to put likes, subscriptions and bells. This is not a wormhole will not tighten. See you in the next issues. For now.